Hello. Today we're going to start section 7.2 parabolas. First of all, let's give the geometric definition of a parabola. A parabola is the collection of all points equidistant from a point, which we will call the focus, and a line, which we will call the directrix. So to draw a simple picture of what's going on here, let's say this random point right here is our focus. This line down here is our directrix. Then the parabola is the set of points that's the same distance from both of these objects. Well, one point that's obviously on the parabola then is the point that's exactly in the middle of these two objects. So this point is part of the parabola. And this point has a special name. It's called the vertex. And now when I sweep out the rest of the points that are equidistant, we get a U shape. So what I mean by the same distance is that if I pick a random point over here, let's call it x comma y, the distance from the focus to this point, which I'll call D1, is equal to the distance to the directrix, which is called D2. Now, my picture isn't perfect because it does look like D2 is a little bigger, but in reality, for a parabola, those two distances would be the same. Now, some other distances that we can label on here is the distance between the focus and the vertex, which is the same as the distance from the vertex to the directrix. This value we call P. It's called the focal distance. Another definition we can introduce here is if you draw a line parallel to the directrix through the focus, that is called the focal diameter. Which has a distance of 4p, which means the focal radius, because radius is half the diameter, is 2p. Well, now we actually want to go through and find the equation of this parabola. In order to find the equation of the parabola, we have to identify what the vertex is. And just like in your college algebra course, the vertex I'm going to label with h comma k. That means our directrix, which is p units below that, is the equation y equals k minus p. Now, why isn't it h minus p? It's because your y value keeps track of your vertical distance. And since I'm moving up and down vertically, that's why we get k minus p. Now, it is possible to have what's called a horizontal parabola, in which case the directrix would be x equals h minus p. But we will talk about that later. And then the focus, again, because it's directly above the vertex, will have the same x value, but the y value will be k plus p. Well, then for the D1, because I want the equation of this parabola, it's the distance between h comma k plus p and xy, so we can use the distance formula. So x minus h squared plus y minus k minus p squared. So I distributed that negative sign. Now D2 is a little bit different to calculate the distance here. It's not really a formula, just noticing that this part of D2 is p, and then this part of D2 is the difference in the y values of the 2 points, so that would be y minus k. So then D2 is equal to y minus k plus p. So then the equation of our parabola is exactly when D1 equals D2. Well, if I write that out, we get x minus h squared plus y minus k minus p squared equals y minus k plus p. And this technically is the equation of the parabola, but we can rewrite it a little bit so it actually looks a lot neater. First, we're going to square both sides. Now, since this is square root squared, it just cancels out. No absolute values. Then I'm going to group the y minus k together like this. So then we get x minus h plus, now I'm going to use the perfect square binomial to expand this. So y minus k squared minus 2p y minus k plus p squared. And doing the same thing on the other side, we get y minus k squared plus 2py minus k plus p squared. Now I'm going to get all the y's on the same side. So I can subtract y minus k squared from both sides. Can subtract p squared from both sides. And then I can add 2py minus k to both sides. So the y minus k squareds cancel out. The p squareds cancel out. This cancels out. And we're left with x minus h squared equals 4py minus k. So again, this is the equation of a parabola. In specific, a vertical parabola. So if this is the equation of our vertical parabola, the information we get is that the vertex is h comma k. If p is positive or greater than 0, then it opens upwards. Otherwise, if p is negative or less than 0, it opens downwards. The focal diameter is 4 times the absolute value of p. Now, the reason why I'm adding absolute value is in case p is negative, and a diameter is a distance. And then the focal radius is just 2 times the absolute value of p. And as a reminder, the absolute value of p is the distance between the vertex and the focus or directrix, whichever you prefer. Now, I'm not going to derive the formula for a horizontal parabola. I'm going to have you do that in the challenge problem of the worksheet for this section. And these are the only 2 types of parabolas that we're going to deal with in this course. But FYI, you can have slanted parabolas because the directrix can be any line. It doesn't have to be horizontal or vertical. It could be like y equals x plus 2 could be the directrix, and then you get a parabola that's facing diagonally. But for horizontal parabolas, the equation is y minus k squared equals 4p x minus h. So the y minus k and x minus h swap spots. The vertex is still h comma k though, not k comma h. So the way I remember it is the x value of the vertex is near the variable x, and the y value of the vertex is near the variable y. But since these are horizontal parabolas, if p is greater than 0, it actually opens to the right. Otherwise, if p is less than 0, it opens to the left. I'm not going to write it down again, but the focal diameter is still 4 times the absolute value of p. The focal radius is 2 times the absolute value of p, and the absolute value of p is the distance between the vertex and the focus or directrix. And that's it for part 1 of 7.2.